So I just want to look at this topic here. Now, I did say to you last week, I think, that I plan to finish this off today. I'm not sure if I'll be able to achieve that actually, but if not, there will only be a slight overflow into week 12. And there's no lab as such accompanying this. What I will do is I'll provide links to a GitHub repo that you can have a look at yourselves if you're interested in looking at it afterwards. Okay, so let's work our way through the slides. There aren't as many slides now on this. It's more the code really that we're interested in looking at, I guess. So this is Maria, the agenda that I want to try and cover. As I say, whether I do it all today or not is debatable. And the kind of overall purpose of this, you see, ye have at this stage now in semester one, you were doing front-end development in the Web App Dev 2 module, and you did back-end development as well. You developed a web API, if you remember, and you integrated them and all of that. And some of you may have deployed both the front end and back end using separate services. It's really a revisiting of that deployment is what I'm trying to achieve, but do it on AWS. And so in this module, we developed a backend web API just on a serverless platform and deployed it to AWS. So what I would hope to achieve is to see, can we deploy a front end like a React app or an equivalent? Are there services available on AWS, which of course there are, to allow us to do that? And also, is there a way of automating the integration between the front end and back end? That's kind of the and maybe the final piece of the jigsaw is, when we do deploy the front end, what we'll get is an AWS generated URL or domain name for our front end, which is usually something, not very intelligible. We'd like to actually give our front end app a custom domain that we can choose for ourselves, just to make it more user friendly, I guess, to use that awful term. That's the very last part of what I'd hope to cover. Probably won't get as far as that today, though. This idea of having your own custom domain for your front end app. Okay, we're going to go back just very briefly to stuff that you would have covered in Web App Dev 2, just to remind you a little bit. Some of you may be developing a web app in your final year projects. You may or may not be using React, but I just want to briefly go back to that area and just briefly talk about this notion of bundling or building a React app. Wait, just give me 1 second. Okay. So this is very much going back to semester one. So we know, and let's just stick with React, although this is not React specific at all. But when you were developing your React app, there was this notion of the difference between a development versus a production environment. The development environment, the idea there was that you used a specially instrumented development server which you started up, and that server then served your React app to the browser. And the nice feature was that you had what's called hot module replacement, or HMR. HMR, as you know, is this notion that if you make changes to the React source code and just save the changes, then those changes are automatically are dynamically pushed to the browser, so you get an immediate feedback as to what the effect of the changes that you made are. Hot module replacement, essentially, it's replacing modules, uh, certain modules within your React app, depending on which modules you've changed. It's pushing those down to the browser so that you can see what the impact of the changes are. That's a nice kind of developer experience, and developer experience. But clearly, you don't want that in a production environment, and you can't have it in a production environment. The same thing is when we talk about the difference between a dynamic versus a static version of your web app. The dynamic version is aligned with this kind of development environment. The static version is what you deploy in a production environment. And all I'm showing you here is I'm reminding you these are the kind of commands that you would have used in the web app dev module to compare and contrast these two. So let's supposing I'm developing a web app, a React app, and I put it into this folder here. I cd down to that folder and I go npm run dev. And what that does is it starts up a specially instrumented web server that provides this HMR feature to you. That's fine. That's our development environment. But then if we want to actually deploy our app or create a static version, we've got to type this command npm run build. The command here, I'm just installing a standard web server. There are lots and lots of standard web servers out there. You can install one using the npm tool. There are a number of them. One of them is a server called Serve. So if you install this package, really, but it's actually a web server, and I'm installing it. I'm installing it globally for no particular reason, and then I build a static version of my React app, and then if I start up this is a standard web server now. It doesn't have any HMR support, and I point it at my dist folder. You might remember the dist folder is where the React, well, when you're using React and Vite together, they place a static version of your React app in a folder called dist within the current project folder. So I'm just starting up my standard HTTP server called Serve and pointing it at my static version of my React app. And then I would, depending on what port the server is using, which I think defaults to 8080, although you can configure it. What it will serve up in the browser then when you browse to localhost 8080 is a static version of your web app. And you know all that from last semester. Let's supposing I have a very simple React app. If I go over to here, so I just grabbed a kind of template React app that's also using the Vite build tool, which is what you would have used in semester one. And so if I just go npm run dev, start up my development server and go to this location, then that's my React app. Fairly unimpressive. Okay, it doesn't really have any functionality other than this guy here. Yeah. I do have a little bit down here though where I do want to eventually hook up my React app to a backend API. And to prove that it works, I just have this simple little message on the home page. But as we can see, it looks like it's not getting any response from the backend at the moment because I don't have a backend. And in fact, I've kind of stubbed out the code that would try to communicate with the backend. But ultimately, I want to connect to a backend, and ultimately as well, I want to deploy this React app to the cloud, to AWS in my case. And I want that React app to dynamically hook up with the web API, and I'll get confirmation that it works or not. Hopefully, when this here will have a different message like you successfully connected to the back end. Okay, that's kind of the context for all of this that I want to cover. So if I go back to the previous slide, so if we talk about just deploying the front end app, forget about the back end for a while. The question is what services AWS, I should really have put in there, what AWS service or services are targeting that aspect of application development. And again, you may already know this, but it turns out that the S3 service, we haven't looked at S3 that much. All I've told you about it in passing was that S3 is simply a kind of a cloud file storage, though we shouldn't use the term file, it's more object storage service. So it's a place where you can store files and or objects. An object can be anything. It could even be a JSON object. Where we can store them on the AWS platform. But it turns out that you can actually store a website, an entire website comprised of presumably lots of HTML pages and CSS files and image files and various other assets. You can actually store them in an S3 bucket. We talk about S3 buckets. A bucket is something like a folder, kind of. But there are differences. And what you do need to do, though, with that S3 bucket is you do need to configure it essentially to tell the S3 service, look, you should treat this bucket as the host location for a website. And really, our static web app is nothing other than a website. Can I just go back actually to VS Code? So I've already ran the command npm run build. That's the command that we use to build a static version of my React app. And if you look at the folder structure on the left here, you will see there is a folder called dist. And if we expand that, we have essentially kind of a website, albeit there's only one HTML file, index.html. And if we looked inside that file, I'm not sure if you did this when you were doing your React development. There's very little in the file. In fact, there's no HTML there's none at all actually. But there is, interestingly, we do reference a JavaScript and a CSS file, as in, where do we do that? Oh yeah, like here we're referencing a JavaScript file, and we're also referencing a CSS file. That CSS? See, there should be a CSS reference. Maybe it's this one. Yeah, sorry, there's my reference to my CSS file. And these two files are actually here inside the assets folder. Again, this should all be familiar to you from last semester. And these were generated by Vite. It essentially took all of your TypeScript code and it bundled it all into one JavaScript file. And if we opened up that file, this is a JavaScript file, but all white space has been, so there's no indentation and alignment. So it's been minified for efficiency reasons. But this JavaScript file was created from the various React components, and there's very little React components. There's only one actually. There's a control or a count button component and some minimal React code in the main file and in the index.tsx file, in the app.tsx. Anyway, so this is a static version of my React app, and I can deploy that to an S3 bucket. But if I configure that S3 bucket to be a website, then I can actually serve my React app from that S3 bucket. Now, to go back to, you can do that manually, of course, but we don't like that. We like to automate these things. So how do I write the CDK code to do that? That's what I'm showing you here on the right. So first of all, I'm just creating an S3 bucket. We've seen that in the lab that you're working on, well, that you were working on last week. The only thing that's slightly different with this S3 bucket is this part of the configuration here. And it's this that tells the S3 service that it should treat this bucket as a host location for a website. And I'm just telling it, look, all I'm telling it here is what's the home page for this website. And it's going to be just called index.html. So there better be a file called index.html inside in this bucket. And whenever we navigate to the bucket, no, sorry, before I talk about that. Okay, so I've created a bucket. It's a standard bucket other than the fact that I have configured it to be a bucket that hosts a website. What I'm doing down here is what I want to do is automate the uploading of my website files, uploading them to this bucket. And that's what I'm doing here. So there's a S3 deploy L2 CDK construct available to me. Yeah. And you can actually upload a number of things within one instance of this, but at the moment, all I'm doing is I'm uploading the dist folder, the contents of the dist folder, and I'm uploading it to this destination, to my S3 bucket up here. So it's as simple as that, really, CDK code. So when I do CDK deploy of this stack, it'll create the bucket, it'll configure it as I've asked it to. It will then upload the contents of my dist folder from the project folder, let's say. And what I'm doing out here down at the very bottom is I'm outputting the URL for my website. And you can see it's a URL that contains S3 as part of the URL domain name, let's say, right? No, it's not it's a very long-winded domain name because it's generated by the S3 service itself. But if I navigated to that from a browser, then I would be served essentially the contents of the index.html file inside in this folder. Well, the index.html file inside in the bucket. Okay. Yeah. I'm not going to demonstrate that, but it's pretty straightforward. Now, the problem though with that is, if your website is experiencing very high levels of user interaction, then there is this kind of single point of failure potentially and availability, which isn't great. It's all targeting my S3 bucket. All my users globally are targeting the one S3 bucket. And so that's going to impact on performance potentially. Maybe not when it's a React app, because once it's downloaded in the browser, as we know, all of the functionality is contained within the JavaScript code that's downloaded to the browser. But more generally, like if it was a website with lots of HTML pages, then as the users distributed globally across the globe are navigating from page to page, all of those are resulting in requests going to my S3 bucket. And so my S3 bucket is being overloaded potentially. So can we improve on that situation? And that's where another service, AWS service called CloudFront comes in. So we're not abandoning S3. It's not a case of will I use S3 or will I use CloudFront? You actually use CloudFront with S3. And CloudFront is simplest way of stating what it is it's a CDN, a content delivery network. What's a CDN? I'm sure you know already, but to give you a kind of formal definition of it. A CDN is just a globally distributed network of nodes of computers, but specifically their role is to cache content uh, so that when a user wants to navigate to the content, in our case, is going to be copies of the pages and JavaScript and CSS assets that are associated with my website, stroke web app. It's going to be caching those locally around the globe on this distributed network of servers. And so when a user wants to load my website into their browser, the way it will work is their browser will first communicate with the CDN server that is geographically closest to them. And it will check to see, has it a cache of the contents that the user is looking for? And if it does, then it'll serve that back to the user. So there's no need to go back to the S3 bucket. So it's just classic kind of caching, really. But the caching is of our web assets in this case. Although it doesn't have to be just web assets, it can be any kind of content, as I'm saying down here, right? We could also use CloudFront with S3 if we had a large number of documents, let's say PDF documents that we wanted to make available across the globe, or videos, or really any type of file, any type of content that we want to make available globally, because there is a high user base that is globally distributed, to make that content available to them, but do it in such a way that they don't experience poor performance. And so the answer always to that when it's web-based is to create a CDN or employ a CDN, content delivery network, to do that for you. The CDN takes care of the caching, takes care of refreshing the caching and all of that stuff, all the kind of cache management. So that's what CloudFront is. It's a CDN. Now, admittedly, these statistics are from around this time last year. Or sorry, the servers, they're given different names. They're called edge location servers. Edge always means it's closer to the user, geographically closer to the user than the kind of centralized server model. They're also called points of presence, or POPs. Yeah. Now, when I looked last year, the CloudFront network had around 400 plus edge servers, or edge location servers, or POPs, distributed around 90 cities globally, yeah, across whatever 47 different countries. Sorry, there aren't 47 continents. So it's a classic. CloudFront is your classic network, content delivery network. It also provides protection against denial of service, but we needn't worry about that. Now, okay, to tie this back now to the CDK. So I guess what we want to do is utilize CloudFront for our website stroke web app that we have uploaded to our S3 bucket. Yeah. And when you're using the CDK, as you know, is all about these L2 constructs that you create within your stack code. And yeah, it's quite straightforward, really. There are actually only two constructs that you need to create in your CDK stack file to leverage this CloudFront content delivery network. There's a construct called the origin. That's easy enough to explain. The origin really will refer to the particular the source for your content, which in our case will be an S3 bucket, but it doesn't have to be. We could be using other, and I'll mention some of the other options that are available to us as an origin. But the simplest one to think about is S3. That contains the source content for us. But in the language of CloudFront, we refer to it as the origin of our content. The second construct that you create is more abstract thing. It's called a distribution. So it's a kind of a virtual representation of your network of nodes, I suppose, if you like. And in our distribution, what we've got to do is we can configure the distribution, and that configuration will control the kind of caching policies that are used by the edge location servers or the POPs for our particular content. Yeah, so just to read it, it's a distribution tells CloudFront where you want your content to be delivered from. Well, that's okay. We link up our distribution with our origin, so that'll tell us where to get the actual content from. But it also it gives the details about how to track and manage the content delivery. So it does all of that kind of low-level heavy lifting for us. So this is a kind of nice kind of visual representation of what's going on here. So you've got a user, looks like in the US side. They're trying to access the website that we've stored in our bucket. But when they submit a request and they have the URL that they will have now will not be an S3 URL, because that would send them straight to the bucket. But it'll be a different URL that will be generated from our distribution that has been created. We'll see that in a moment. So that URL, the first thing it will hit will be one of the edge location servers or POPs for our particular one of the CloudFront POPs. Let's stick specifically with CloudFront. It'll eventually get routed to the nearest CloudFront edge location server, and in there will be details of it will first of all check, does it have that content cached locally? And if it does, it serves it to the user. If not, it goes back to the origin for the content that will be delivered back to the edge location server. It'll cache it and then serve it to the user. But of course, the benefit is when the user, if any other user in this region wants to access the same website, stroke web app, they will get a much quicker response because it's now going to be cached locally here. Just another visualization of the same thing. So you've got your client, your browser. This is what it wants to, it's the content that it wants to load into the browser. And okay, we're just specifying what are we doing? We're just specifying a particular image from a particular location. Where's the domain name? Well, there's the host there. Okay, so we're referring to a particular image. So this might be part of, it's already loaded the home page, and in the home page, there's a reference to a JPEG image. So that triggers another request back for the JPEG image. And that's the request that we're seeing here. That request will be routed to the nearest edge location server to this client. It'll check the cache. If it has it, it'll serve it. If not, it goes back to the origin, which is our S3 bucket, or as I'll explain in a minute, it could be some other type of HTTP origin as well, like an API gateway would actually work. API gateway would not be serving HTML, but it would be serving It could be serving images, or it could be serving JSON responses, the JSON responses would be cached here as well. So anything can be cached here. It's just data, I suppose, more generally. Okay, so that's how that's another visualization of a more kind of fine-grained visualization of what we want to achieve. Okay, just a little bit about CloudFront origins. There are two types of origins. S3 is the one that I keep talking about. Now, if S3 is the origin for your content, clearly we don't want anybody to be able to access the bucket directly. We'd like to secure it so that this S3 bucket that contains the content is only available to our distribution construct, if you like. And it's slightly odd, but the way we do that is we create there is a third construct called an origin access control. It used to be called an origin access identity. And I'm actually using this origin access identity construct within my code that I give you. But essentially, an origin access identity is a kind of an abstract identity. Always kind of typically refers to a user, but in this case, it's something more abstract. We can create this kind of abstract identity, which we call an origin access identity. It's a bit like an IAM user, and we will give our origin access identity exclusive rights to read from this bucket, and nobody else has access to the bucket. And then we link the origin access identity to our distribution. And that's just a way of securing our S3 bucket. Now, you can actually use this whole configuration, this CloudFront CDN and S3 as your origin. You can actually use it for uploading as well as downloading. Uploading we often refer to as an ingress. So if you wanted to give users globally distributed the capability to upload files or objects to your S3 bucket, but you want to do it utilizing kind of our CloudFront CDN option, then you can still do that actually. We won't do it in our labs though. And you get the kind of the performance benefits because they're really your client. If we go back to here and we're doing ingress, sorry, if we go back to, can I go back? Like you're uploading it to just the local edge location server. And then it will respond saying, yeah, I got that. So you get a much quicker response. Now, of course, the edge location server, it will take care then of uploading it and completing the upload to the S3 bucket. I guess if there is an error, it may come back to, I haven't looked at it really, may come back to the client, but the initial response will be that I have received your upload. So you may have to build some extra asynchronous coding in here in the client if the upload happens to fail. For the kind of happy path case, though, you're going to get a much quicker response saying your upload has been successful, initially anyway. Now, whether you want to cache the upload or not, again, that's configurable. Anyway, we won't be looking at ingress at all. If you don't want, if for whatever reason S3 is not an option, there are other options, okay? API gateway, an application load balancer, which some of you would have looked at last year. Even an EC2 instance, you might actually want to be storing, you might have a website that's running on an EC2 instance, and that website you want it to be accessed globally in an efficient and a performant way Well, stick a CDN in front of your EC2 instance, i.e. stick CloudFront in front of your EC2 instance that's hosting, sorry, your website, and you get the exact same, you get all the benefits that we've already talked about. The only reason I'm making a distinction, I'm saying S3 website here, and I'm saying S3 up here as well, is when we talking about S3 up here, we're talking about S3 just as a location for content. It doesn't have to be a website. Yeah, it can be any content. I've already kind of made that point. But equally, if it's a standard multi-page website that you have currently hosted on S3, then you can, as I say, you can stick a CloudFront CDN in front of it and get the performance benefits that we've talked about. So in a way, these two kind of overlap, but some of the documentation makes slight differences or distinctions between them. Again, is there anything new here? Well, the only thing new in this kind of visualization is the role of the object access identity, or what's now called the object access control. That's the kind of security side of things. As I already said, it's only this identity, or let's put it this way, whoever can acquire this identity will have the rights to read from the bucket and potentially write to it as well. What we will be doing is we will be linking the object access identity with our particular CloudFront distribution. And so it's that CloudFront distribution will have the necessary access rights to read from the bucket. Nobody else can access the bucket directly or indirectly. Right. Suppose I want to deploy my simple React app utilizing CloudFront. Let's put it like that. And I will use S3 as my origin, but I won't be configuring that S3 bucket as a website. It's just going to be an ordinary bucket with stuff in it. But by linking it up, connecting it with CloudFront, I can tell CloudFront that if anybody uses the CloudFront distribution URL without any kind of qualifier, then serve them the index.html file in that bucket as their initial kind of response. And if voila, they're going to have my React app sent to their browser. Now, to look at the code then, yeah, let's look at the code. So we're now looking at a CDK project. Previously, we were just looking at a React Vite project, and all we're interested now there's a lot of stuff in here that I'm not interested in right now. Like we're not interested in any lambdas. We've no backend at the moment. It's just all front end. I do have looks like I have some local, some custom constructs. I'm not interested in any of those either for now. The only file I'm interested in is this one. Which one is it? Is it this one? Yeah. I should have given it a different name because eventually what we're going to do is we're going to roll this forward into a full stack app. But for now, it's just a front end app. So the name here is a bit misleading. It should really be front end stack app. So let's just look down through the stack file itself. As before, we have our S3 bucket, and I've purposefully left these two lines here, but I've commented out, and the reason I'm doing that is to reinforce the point that this is just an ordinary S3 bucket. I'm not configuring it as a website, as a bucket that's hosting a website. It's just hosting content. So it's just a bog standard bucket. Just give me a minute. Here I'm creating an object access identity, this kind of abstract identity for myself. Very little configuration, just create one. So this here is, creating this thing here. And am I linking it to the bucket? Doesn't look like I am. So it's, for the moment, it's just a standalone. Oh yeah, sorry, here I am. Look, I'm saying grant read access to this origin to the bucket, to my source. So that's what gives it, so I have full control over what permissions this object access identity has to the bucket. And I only need to give it read access to my bucket. Source is my bucket reference up here. And then the main piece here is, here's how I create a distribution in CloudFront anyway. I'm sorry, in CDK. So it's an RL2 construct that's available to me. And just to skip down through it, here we're telling it what's the default file that should be served to a client if they don't specify a specific file. Yeah, so I'm serving it index.html. That index.html, of course, will come from whatever the source that is linked with this distribution, which I talk about later on in this configuration. What else? Just protocol version, whether it's going to be using HTTP or HTTPS. So it looks like I'm using HTTPS as the default protocol, communication protocol. And default behavior. Rather than look at it in detail, really, this is where I'm kind of linking it to, let's just see now, I'm linking it to my origin, if you like, to my S3 bucket. Is that what I'm doing there? I'm making a reference to the object access identity. I also have a reference to the bucket, essentially. Yeah. The reason this is strike through here is because the particular L2 construct that I'm creating here is being deprecated. So I do need to find what's the new variation on that, but this still works for me, which is okay. So really, I'm kind of just, look, it's just kind of boilerplate. This is how I'm linking my distribution to my origin and also tying in my object access identity. I think the rest we can just ignore for now. Let's see. Okay, well, it's clearly controlling what kind of methods I'm allowing clients to send. So it looks like it's only get and head requests I'm allowing. And viewer protocol, let's not worry about that. That's kind of outside our need to know kind of. So that creates my distribution. So when I deploy this stack, kind of the effect of all of this code here will be to essentially send out some new information to the 400 plus POPs that are linked to that are part of the CloudFront content delivery network, so that they are all aware of this new content that I want to make globally accessible. You know, that's a very kind of vague explanation, but that's kind of the effect of it. And the last piece of the jigsaw is I need to upload my contents to my origin. And we've already kind of seen that. Is that what's going on here? Yeah. And creating a new S3 deploy, as it's called. But really the purpose of this piece of code here is just to upload the contents of my dist folder to my bucket. And let's see, what's that destination bucket? That's okay. And I'm also tying it into my distribution. So I'm connecting them all together, if you like. I tend to treat this somewhat as boilerplate code, though. The last thing I'm doing is I'm outputting the domain name that will be created for my particular distribution. And I've already deployed this stack. And if I look at this is the domain name that was created from my distribution. So if I grab that, go to a browser, change this to, now before I actually, if I open up my developer tools as well, actually, and if I go to the network tab, and now I paste in my URL. Okay, so I got my content, and here's what was actually sent down to the browser. Now that tallies with my actual content. I've got a JavaScript file, index hash.js, index hash.css, an SVG file, a vconfig. These are essentially these two images here. These here, this JS file, CSS file, that corresponds to, if I go back to VS Code, and if I go back to my original React app, it corresponds to these two files, this content, if you like. And where did it actually get those from? Let's go back to, well, sorry, before we do that, if I select any one of these, sorry, I'm jumping around a little bit now. If I actually go to the bucket, sorry, let's look at the bucket. If I go to S3, and I find the bucket that has been created for me, which I think is this one here. And it has a file called index.html. That, of course, corresponds to corresponds to this index.html here. There's an assets folder and all of this stuff. And if we go back to our bucket, we have our assets folder. And if we drill down into it, we have our actual JS, and is that what we have? Yeah, our JS and our CSS file. So that's all back at the origin. Now there is a CloudFront service, of course, and there's a management console for it. So if I just go to that, here's the distribution that was created. We don't need to drill down into it for now, but in my browser here, so when I hit return on this URL, what happened was here I am. I browse. It went to my geographically nearest edge location server. It would not have had the content, so it would have went back to the bucket. It would respond with the index.html. That would have been sent back to the browser. Then the browser had references to my JS and my CSS files, so they would similarly have triggered more requests to my nearest edge location server. It wouldn't have had those either, back to the bucket, and so on. And if I look at the details of the network communication that happened between my browser and whatever it was talking to, which was the edge location server, then I can actually see evidence of the fact that the edge location server did not have the content that I was looking for. It wasn't in its cache, which it wouldn't have because this was the first time I've browsed to it. Although having just said that now, it's going to be a cache. No, I'm actually telling you a lie because I just played with this a little bit earlier on. So it will actually have cached it, I think. Let's just see. Did it get a cache hit or a cache miss? That's really what I'm trying to get at. So if I select any one of these files, I'll select this one. And let's look at the headers. The HTTP response headers is what I'm looking at or interested in. Here are the response headers, and one of them is called Xcache, and it's telling us, oh yeah, okay, maybe it flushed when I was browsing earlier on. It would have cached them, but that cache may have expired. You know, its TTI would have expired. So it's telling me that the edge location server that I am communicating with um, had a cache miss for for this particular file, for the JS file. Yeah. Now, if I do a couple of more refreshes, then it's eventually going to change to a cache hit. So let's just do a couple of refreshes. Okay, I've done 3, and what happened? Select it again. And I'm still getting a cache miss. Why is that? Let's see. Oh yeah, maybe I didn't refresh them properly. Let's try again. Select. and I'm getting a cache hit this time from my edge location server. Okay, so where are we? We now have CDK code which will create our origin, our S3 bucket. It will create a CloudFront distribution specifically for this origin. It will create an object access identity and give that identity repermission on the bucket, link that origin access identity to my distribution, my CloudFront distribution, and then finally upload the actual content to my bucket, and that's it. But there's no backend at the moment still, though. We don't have it communicating with any backend. So is that what we should talk about next? Let's go back to the slides. So I've demoed that for you. All I'm showing you in this screenshot is this idea of looking for the cache hit and the cache miss. That's all those two slides are just confirming and showing you how to, if you're not familiar with the Chrome developer tools, I'm showing you how to get access to the network communication that's going on behind the scenes. A little bit about the cache, CloudFront cache. Well, we know what a cache is. It's a high performance, kind of short-term key value store. It's always key value stores. The CloudFront cache lives at each CloudFront edge location server. So each edge location server will have different cache content from the others. Just depends on what the users within a particular geographical location are looking for or navigating around. As we know with any cache, CloudFront identifies each, I'm saying here it's an object, but it's, whatever the types of files are. It identifies each object in your cache using a cache key. Now we can control what the structure of those cache keys are when it's and we do that within our CloudFront distribution configuration. That's one thing you can control. We didn't do it in the code that I showed you. We just let it use its kind of default key construct, and the default is, so I'm not saying it here. Okay, I'll talk about the default in a minute. What else are we saying? We want to, well, that's always, we want to minimize maximize the amount of cache hits. That's always the case with caching. You can also do something called cache invalidation. If I change my React app, make some changes to the code, excuse me, I'll have to do CDK deploy again to upload the new content to my bucket, to my origin. And clearly, the caches on the edge location servers, they should all be flushed automatically. And that flushing is called a cache invalidation. So every time you redeploy, a cache invalidation happens. Now, you can actually force a cache invalidation, which you would tend to do when you're testing all of this before it goes into production. And it has the same kind of effect when you do a manual invalidation. It essentially sends a request. The CloudFront service will send a request out to each of its POP or its edge location servers, telling it to flush the particular cache that's related to our content. And you can be more specific. Maybe there's only certain parts of the cache that you want to have flushed because the cache could grow, depending on how much content is in your origin. Um, you may not want to flush the entire cache every time. You just want to flush part of it. You can control that when you're doing manual invalidation, and you can control it when you're doing automatic invalidation. Okay. The cache keys, I was jumping ahead there. The cache keys. We know what the role of the cache key is. It uniquely identifies a particular item in the cache, where the item in our case would relate to one particular file, be it a HTML file or a CSS file or a JavaScript file or an image file. Now, the key itself, the structure of the key, if you like, there's a default structure that CloudFront uses, and the default is it simply takes the domain name and path part of the resource that's resourced from a HTML point of view. It takes that part of the URL to create the key. So, for example, if a client browser, in our case, let's say, sends a GET request or issues a GET request for this particular uh, web resource or web asset, then whether it's in the CloudFront cache or not, whenever it does finish up in our edge location cache, the key that will be assigned to the actual HTML file corresponding to this will be all of this here. That's what I'm saying kind of down here, that the key will be actually the domain name plus the resource path name as well. Now you might notice over here that there's actually a query string as well in the request, but by default, the query string is not part of the key. If you want the query string to be part of the key, then you can actually configure your CloudFront distribution to achieve that. And in fact, it goes broader than that. We can't see from here, but there may be cookies accompanying this request. There certainly will be HTTP request headers accompanying the request. And maybe some cookies and some of the headers, maybe they actually influence the response that is sent back to our browser. And so maybe we want cookies and HTTP request headers to be part of the actual key as well in our edge location cache. So, and that's really what I'm kind of saying down here. If query string parameters and our HTTP headers and our cookie request cookies, if they all have an influence on the response that is ultimately sent back to the browser, then we should include those in the cache key. CloudFront will take care of all of that for us. We just have to tell it what cookies and what request headers and what query string options should it include in its cache key construct. Just a bit more detail. We don't really need to go into all of this kind of level of detail, though we certainly won't be playing with it. But if we just take the case of HTTP headers, if we want HTTP headers to be part of the cache key, then the options that we have in terms of configuring it is we can say we don't want any HTTP headers, which is obviously the default. We could specify a whitelist of headers that we want to have included in the key itself. And similarly for cookies and query string options. So lots of configuration options available to us. Now, that's what's referred to as your cache policy associated with your CloudFront distribution. And this cache policy is something that we can configure in our CDK code. There's also something called the origin request policy. Now, where that comes in is, if I just go on to the next slide. So you've got a client here, and it sends a HTTP request, which initially will be dealt with by one of our CloudFront edge location servers. And let's supposing the request has some cookies, and it has some headers, and it has some query string options in it. Now, what parts of all of this request, let's supposing a cache miss occurs, which means our edge location servers needs to talk to the origin. The origin in this case, in this image that I got somewhere, happens to be an EC2 instance, but it would be an S3 bucket in our case, and it would be sending the request onto the S3 service. But what parts of this request that came from the client need to be forwarded on to our origin? Do we include all of the headers, or only some of them, or none of them? Do we include all of the cookies? Do we include all of the query string options? Okay, all of that is what's referred to as your, if I go back again, as your origin request policy. What do you forward on to the ultimate backend? And that again is something that you can configure at the CloudFront distribution level. And so that will be pushed out to all of the edge location servers so that they know how to deal with requests that come from the client and how it should forward them on to the backend if it gets a cache miss. Okay, and so there's lots of options here which we needn't go into. So really all of this is kind of by way of useful information that I'm making available to you. Cache invalidation. I'm just going to skip over that actually. Are we on time? Okay, let's move on to a proper kind of full stack web app where we've actually got a front end communicating with a back end, where our back end is also deployed on the AWS cloud. And because we have developed serverless backend, we'll just use that as our API backend. So our objective is to use the CDK framework to provision whatever cloud infrastructure we need to deploy a full stack app, which is comprised of, as I've stated. Clearly, we don't want to do anything manually or as little as possible. We want to automate the whole lot. And we kind of have two parts. We know how to automate the deployment of our serverless backend. We know how to deploy a front end. The tricky part, though, is how do we essentially kind of inject the back end domain name into our front end code? How does it kind of pick that up dynamically? We could hard code it. We could we could automate the deployment of the backend first, then get the URL or domain name that was generated by the API gateway service and hard code that into our React app, and then just deploy the React app separately. But it would be nicer if the React app could kind of pick up the domain name for our web API somehow as part of its deployment process. Now, there's probably a couple of ways we could do this. I'll just show you one way. So it's certainly not the way or the only way, but it's the one that kind of works quite easily, and it's pretty easy to understand, actually. Okay, so to do that, I should have actually deployed it. I need to uh, destroy the deployment that I already have. So we let that work its way through, and I'm going to change over to a different branch. And do I need to, I think I need to go back to my React app actually. Now just bear with me if you don't mind. What do I need to do here? So as you know from last semester, if you want to communicate with the backend, that's where you use, that's one use case for this use effect hook. So that's really all I'm doing here. I'm bringing in a use effect hook. I'll explain this code after I've started the deployment because that's the slowest part. What did I call it? Sorry. That message. And I need to rebuild this web app now. So npm run build. And I need to grab the dist folder. The dist folder. Now I'm doing a manual copy of it over, which isn't great, but I'm just going to take that one, copy it over to my CDK project, which is this one. Check now that I switch Switch branches here. Yep, okay. This is my CDK project. Copy over my new dist folder. I'm going to CDK deploy this full stack app, and as it's deploying, then I can explain. There's not a lot of new code, but we'll talk through the code itself. So CDK deploy. Finished. Oh yes, okay. Now there is actually two stacks at play here, but we needn't worry about the second stack for a while. So I'm just going to ignore the fact that there are two stacks. Now the deployment is quite slow because of the distribution. You know, when it's creating a distribution, it obviously has to push that distribution out to each of the edge location servers and get a response back from them saying, yeah, we have that. So that's what slows down the deployment. So we let it work away and just keep an eye on it. Now, the only file that I need to look at right now is, as I said, there are actually two stacks here, but the only stack that I need to talk about now is this one. The reason I got two requests to confirm the deployment is because I have two stacks, so that's fine. Let them work away. Can I look at this file? Okay, here's my main stack. Now, for convenience, I've created some custom constructs as well. So all I'm doing in my main stack is I'm creating an instance of app API, which will be my backend, and I've put all of my backend code into its own construct, which actually has nothing. It's a simple serverless web API. Okay, nothing additional there. So we needn't really look at that at all. And I'm also, it looks like I'm creating an instance of a custom construct called front end app. We know a lot about what that contains. That's where all the CloudFront distribution and my origin access identity and uploading of my React app to my S3 bucket. That's where all that goes on. But there is some additional code in there as well. So let's look at this construct, which is up here. Uh, let's just go back to the stack file. Sorry, I did skip over something there though too, which so I'm creating my backend REST API inside in this construct here. And when I'm creating my front end construct, I am accessing the URL of the REST API that was created in the app API construct. Okay, so I'm grabbing that and I'm passing it into my front end because my front end wants to know what is the domain name of the REST API that was created by this guy. So that's what I'm doing there. I'm passing that in as a prop into my front end app construct. Don't worry about this or this for now. Okay, that's in the next lecture. I'll cover those. So this is the key one. I have to pass in the dynamically generated your domain name from my REST API. I have to pass that into my front end construct. And if we look at the front end construct code, a lot of it is similar to what we were looking at a while ago, as in, let's see, don't worry about this either. Here we're creating our S3 bucket. Again, it's not a website, it's just an ordinary bucket. I'm creating my origin access identity. I'm giving the origin access identity permission, read-permissions on the bucket. I'm creating my distribution, all of which is the same. Okay, this is different, but we're not worried about that for now. The rest is the exact same as before. Is it? Yeah, it's all the same as before. We needn't worry about this for now. The Route 53 stuff, that's for the next lecture. What I'm doing here is I'm just creating a JavaScript object. And there's only one property in it. And that property, its value, is the domain name of the REST API that I have passed into this construct, which I was talking about there a few moments ago. So I'm creating just a standard JavaScript object, okay, TypeScript object, where it doesn't really matter. That's all I'm doing there. And what I actually want to do with that JavaScript object is I want to uh, store it in the same S3 bucket that contains my content, my React app, static version of my React app. And that's what I'm doing here. Okay. This is just taking the contents of the dist folder, which contains my static version of my React app. This is saying upload the contents of this object up here and store it in a file called config.json. Could have called that anything, right? So when we actually look at the inside the bucket, we should see this config.json file, and it will have the URL, the dynamically generated URL of my REST API. So what's the benefit of that? And if we just finish off, there's nothing extra in this file other than just outputting the domain name of the CloudFront distribution that has been created for me. Now, unfortunately, it's still deploying down here, so that's okay. Let it work away. So what's actually going to happen is my React app is now going to be able to access, essentially, it's going to be able to access this object because if it makes a fetch request for config.json, if I have a fetch request for config.json within my React code, and because the React code was stored in the same bucket as the config.json, it's a simple, it's a simple fetch request. So let me show you what I mean by that. If I switch over to my React app, and I have a folder here called API, and there's a file called backend.ts. And this is kind of similar to where you would have put your TMDB calls in the web app dev module last year. So let's see. I'm importing this. So if we go to that file, we're looking at a file called config.ts. Here's config.ts. And lo and behold, one of the first thing that config.ts does is it does a fetch call on config.json, and the location of config.json is in the same location as as this file, if you like. And this file would be in the uh, will have come from the S3 bucket. Let's put it like that. So now my React code has accessed this file, which contains within it the domain name of my web API. And all it's doing here is it's just creating a local object structure. And I'm putting in the URL of my REST API. And so now, essentially now I have I have a dynamic reference to my REST API, and it's being made available for me. I've just made it available via this method here, right? Because all is that what I'm doing? Sorry, this function. Let's see. Oh yeah. Well, sorry. What this function does then is it makes in this case, a HTTP GET request to my domain name of my REST API, to whatever the kind of the main path of my REST API. Okay, I could have added on something onto the path, like, /movie/movie ID or whatever. But as long as I can show that I can access the root path, I should have said, I'm just trying to access the root path within my REST API. And in my REST API, even though I didn't show you the code, the root path is linked to a Lambda. And if we look at the Lambda, back to my CDK project. So the deployment has worked. Hopefully this all works. I didn't show you the REST API custom construct that I have, but that's because there's nothing really uh, new in there. Here I'm creating a REST API, and it just has one endpoint, and it's linked to a Lambda, which is this Lambda here. Don't worry about all that stuff. Here's the Lambda, and all the Lambda does is it returns that as in the response. So hopefully I can see that popping up in my in the home page of my React app, and that will have proven that it did actually make the connection. Fingers crossed now that all of this works actually. Let's go back and let's grab the domain name for the CloudFront distribution that has been created for me, hopefully. Did something, okay, which is here. This is actually just this is the domain name of the REST API. Let's just try that as a matter of interest. Okay, let's not worry about that. Let's do the other one though. Let's take this one. Here now, there's something I've forgotten, but let's hope for the best. Oh, well, it worked. Okay. Success in contacting, connecting to the API. So that came directly from my Lambda, as I've shown you. And so, yeah, so what's happened? So my browser, my client, sent a request to, let's bring up the picture. My client sent a request to the nearest edge location server. Eventually, the React app, because let's say it was a cache miss, back to my S3 bucket to get my index.html, back to here, back to here. Then it requested the JavaScript and CSS. They came back, and also and then the JavaScript code, my React code, ran within the browser. It made a request to my REST API. Now that request does not go to the edge location server. That request goes directly back to, my REST API. I'm not using the CloudFront distribution to cache any requests that go to the REST API. I could have, okay, but that would require a lot more work on my part. So yeah, so that was the only thing that distinguished this demonstration from the previous demonstration. The fact that my React code running in the browser can now communicate with my REST API because it got the well, before it made the request, it had to get the URL. And how did it get the URL or domain name of my REST API? Well, there was in my React code, it tried to access a file called config.json. That request did go to the edge location server because the config.json is within my S3 bucket. And maybe I should just show you that. I bring up the S3 service. And which bucket is it? Looks like it's this one. And there is config.json there. Can we look at it? Or we could open it up. I'm not sure how you open up these files, but how do I open it? Oh yeah, that's the contents of the file. And that is the URL of my REST API. Yeah, this is the exact object that we created in our stack. Just finally go back to that, which is, let's see. Yeah, this object here. Okay, so there's a lot of moving parts there now, admittedly. But to complete the picture, the JavaScript code in my browser sent a request to the CloudFront edge location server for a file config.json. If it hadn't cached it from previously, we'll go back, get it, send it to the browser, and now my React code can now make a request directly to the REST API. So they're dynamically hooked up to one another. Okay. The last piece of the jigsaw, which I knew I wasn't going to get to, but where are my slides? The last piece of the jigsaw is, to give my React app let's see, sorry. a custom domain name that I can control. In my case, can I actually prove it to you? I think in my case, the domain name is my app. myapp.dermotoconnor.com. That's my custom domain name for this particular app. So how did we actually get that to work? And again, it's um, CloudFront Distribution is doing part of that, but not really. It's a separate service called Route 53, and that's the last part of the jigsaw that we need to look at, which at this stage now I'll have to look at in week 12. Okay, I should stop here at this stage. Um, eventually I will make the GitHub repo or the CDK project that I'm deploying. I'll make this available to you from my GitHub account if anybody is interested in poking around. It's, as I said, it's not really required for, certainly for the assignment. It's not required for the exam either. So it's very much in your own interest. Okay, that's all for now. I'll pause for a second just in case there are any questions related to this or anything else. No, I'll be available tomorrow morning and during the labs. Thanks. Bye-bye.